ওটা এই লোকে ফোন হারিয়ে গেলে যে হাতে ফোন দিয়ে বলছি আমার ফোন কর
Yeah, so there will be people going from here. If you're taking an Uber or something, do on Google, do old transit house, JNU. Now apartment is 52.
You can share.
But then,
ড্রাইভার আমাদের পুরো রাস্তাটা বুঝিয়েছে, কিন্তু আমি তো তখন ইয়েতে ছিলাম, আমি বুঝতে পারি।
Good to see you all. আচ্ছা, ইউটিউব কাজ করছে? Someone.
যদি ইউটিউবটা কাজ না করে আমার
This is a problem, right?
Sir, actually we are live now. It's
Huh?
for live streaming.
Oh, all right, but it's still a problem because someone kind of
people cannot
go up and down.
লাইভ অ্যাক্সিডেন্ট দেখা যাবে।
No, you won't see that. All you will see that the camera is falling. You won't even know. You will miss the fun.
Yeah, live streaming हो रहा है.
But those things you
So
can
you
cut.
attempt to check your phone is not live.
No, it's a live streaming. I can't cut anything. Later we can.
You can cut.
কিন্তু তোমায় বাদ দিয়ে, তোমাকে বাদ দিয়ে দেবে।
Moumanti is really speaking English.
এটা বেশ দারুণ ছবির মতো লাগছে। তাই না রাহুল দা? এটা বেশ দারুণ ছবি লাগছে।
You know, Moumanti, the first time, I don't know what you, Moumanti, the first time we gave a talk here, so he said sad. In Bengali, sad is sad. Sad. Come in the morning. So he comes in the morning. And Moumanti, normally his decibel level is really very low. Suddenly on my office on the blackboard starts, good afternoon everybody, loudly. I said, so Moumanti, it's morning. I said, কুমারজি আমার অফিসে প্রথম টকের আগে এসে বলে স্যার আমি প্র্যাকটিস করবো তোমার আগে আমি বললাম ঠিক আছে সকালে চলে এসো। সকালে কুমারজি কামস and Kumarji, he speaks very softly. Suddenly he says, good afternoon, everybody. I told everybody is only me. It is morning. Nasa practice could
लाइट में फ्लिप हो रहा है क्या? लाइट
Yeah. He is already at IISER.
ये स्क्रीन को ऊपर कैसे ले जाना है ये प्रोजेक्टर को?
Last night around 1:30, I asked him, he had just landed and he was going to IISER. He doesn't like it.
ছটা মানে ছটা তুই যাবি? ওই তো বলো তোর সঙ্গে কথা বলে বলে থেকে যাচ্ছে যখন চাস।
But then he's also
now look. नो शट डाउन नहीं करना, देवोशी नहीं शट डाउन नहीं करना, वहाँ पे पॉइंटर होगा ना, हाँ वो उधर पॉइंटर दे दो मेरे को, उधर ना रिमोट रखा है प्रोजेक्टर, उधर पोडियम पे प्रोजेक्टर का रिमोट है,
আচ্ছা রবি আমাদের ক্যাম্পাসে আগে কোনোদিন এসেছেন? আমি অডিটোরিয়াম চিনতে পারি।
So shut down, escape कर दो इसके।
চলে আসবে তার মানে হ্যাঁ চলে আসবে কিন্তু আমি আমার ফোন আছে
Okay, welcome everyone to this conference in honor of Professor Rahul. There's nothing to announce. There are some pads kept. Those who require, only require, you can take a pad as well as a pen there. And there are boards kept outside. If you want, if you're really inclined to do research, and you can use those boards outside. There is a lounge where you can go and have coffee. If you are not keen on intending to listen to any talks, okay. With that,
I'm going for the coffee.
yes.
So strong encouragement to go for coffee and less encouragement to go to the board.
So there's nothing more to announce. The first session will start soon.
Okay, thank you.
Cool.
Sir. It's a great honor to chair the first session in the conference in honor of the great actor Rahul Roy. The first speaker today is Moumanti Podder from IISER Pune, and she's being a social person. She's going to tell us about social learning.
I'm not a very social person. Okay, sure. Pens.
But you need a collar mic, sir? What about
Color mic is required.
No sir, color mic.
I think we need pens.
Pens.
Can you ask Subhash?
No pen.
Here?
তুমি যাচ্ছ চাকমাটা অফিস and also a duster
না, just a
to why
ও এটা কাপড় দা।
তুমি কোয়ালিটিতে বলো একটা ডাস্টার নিয়ে
এই কোয়ালিটিটা
a duster
লাইভ না, একদম না। লাইভ ইউটিউবে চেষ্টা করে
Time has started.
Timing to jump.
Time has started.
না, ওরম বললে হবে না। মজা দেয়।
No,
No, the thing is because of recording.
online.
Because of recording.
Suresh ji, काम कर रहे हैं ना?
में और कोई
yes good you got the mask so you can very
I have not been wearing it till inside the room again.
it's quite bad JNU is still better because it's fuller surprisingly because of in JNU but you know there should be JNU season around
Connect to the Wi-Fi yesterday. You connect to internet yesterday?
Inside the room it doesn't work. But once I come and sit on those sofas, it works.
Our cables are very old, and that gives all these problems. We are in the process of changing them. Hopefully, in a year or two, it will be all renovated.
You have a genius speaker. Partner speaker. Partner speaker. You have got a genius speaker. Genius, no, sir.
this is a Loda
Genius.
একটা লোহা জিনিয়াস প্রোগ্রামার ছিল সেটা দিয়ে বাবা বিশালদার আছে একই টিচার
ও আচ্ছা আচ্ছা যেটা কি বলে অপ্রকাতে হয়েছিল
You understand Bengali, I hope, because you have no choice.
Approximately.
Approximately. Good.
You'll learn it by the end of this.
Yes. Social learning.
বাইরে বাইরে কোথাও লাগিয়ে দাও
Maru, since you are running around, if you can get some color drawings. Thanks.
Please start.
Okay, thank you so much. Just want to mention, I think I first met Rahul in Shanghai, not in India. Anyway.
Yes.
Chinese connection.
Actors go everywhere.
Yeah.
It's a more likely event in you.
Vietnam is more like.
He's all over the world.
Except India.
Oh, just like.
It seems like she only wrote things, not right.
So this is a joint work with Professor Amish Sharkar. It's a model of social learning where I consider a rooted tree T sub m, where the m indicates the number of children of every vertex. Oh, okay. I'll try to remember it. Okay. So let's say and so on. So this would be m equal to 3. And at every vertex of this tree, there is an agent. Okay, and the agents are they're the ones who are trying to learn something in this model of social learning. So there are two technologies that are available. We call them B and R. Okay, so they really stand for like B as in blue, R as in red. So because they will also indicate the color or state of every agent at any particular point in time. And the process we are considering is indexed by non-negative integer terms. So T will belong to the set of non-negative integers. So I would think of the time points as like an epoch, and during every epoch, every agent chooses one of these two technologies and adopts that. So I would say that this C sub T of B is the technology adopted by the agent of B. So I'm just writing by B during epoch T. Okay. And equipped with whatever technology this particular agent is choosing, they perform an experiment which we could consider whether the experiment is yielding a satisfactory result or not. So in that sense, the experiment is either a success or a failure. So I say that xt of b, this is 1 if the experiment by the agent at b, I'm not writing by the agent at b, just by b, during epoch t is a success, and it's 0 if it's a failure. Okay. And we assume that if during the epoch t, the agent at b has adopted the technologies capital B, blue, then the probability of success here is P sub B. Okay, and conditioned on this event, xt of b is Bernoulli with probability, success probability P sub b, and conditioned on the technology adopted being R, XT of B follows Bernoulli with success probability P sub R. Okay. And there will be one other Bernoulli random variable involved, but we'll come to that in a bit. So where's the learning happening now? So at the end of every epoch, every agent will update the choice of technology, and that update happens according to the following rule. So let's say this is the vertex B, and there's an agent stationed here, and let's say that the children of B are B1, B2, so on up to B sub n. And what the agent of B does at the end of epoch T is that they consider the technology adopted by each of these agents during epoch T, and what was the outcome of the experiment performed by each of them during epoch T. Okay, so the agent here would look at two things here. They would compare two objects. One is this. Let me write it first. This counts the number of children of B that adopted technology B during epoch T and got a successful outcome by performing the experiment using that particular technology, so B. And the other one is this. Okay, so this is the number of successful outcomes achieved by children of B who adopted the technology R during epoch T. Okay, so if this inequality holds, then the agent at B during the next epoch adopts technology B. Okay, if this happens, the reverse inequality, then the agent at B adopts technology R, and if the two are equal, then they set so this is B with probability half and R with probability half. So there is one more Bernoulli random variable, fair coin tossing that goes on here. Okay. So in some sense, the agent here is asking its children, okay, you have adopted certain technologies during a particular epoch. You tell me how you have performed having adopted those technologies, and then accordingly, I will make my decision on the technology to be adopted during the next epoch.
And at time 0, it's IIT.
I was going to come to that. Yeah, because so far I just wanted to describe the update or learning rule. So this is the update or learning rule.
Sorry to interrupt. So it does not matter what is the state the technology we already has. So it only wants to look into
looking at
the children.
Yes, that would be sort of the next thing to consider. Okay, and now what we want to understand, so what Rahul just asked. So we start with some initial configuration, and this initial configuration is where we assign IID technologies to all the agents on the tree. So C0 B, this is IID, and well, writing one on doesn't make sense. So B with probability pi naught, R with probability 1 minus pi naught. Okay, so this is obviously for every PV. And then we want to see how these technologies diffuse throughout the population of agents, meaning that when this process has been run for a long enough time, do we get to see that one of the technologies dominates the scene or not? And so it would be great to be able to say this over the all possible values of PV and PR, but the rigorous analysis that we could do were for a few different cases. So for m equal to 2, we could cover all values of PV, PR in 0, 1. For m equal to 3, we covered the case where the technologies perform similarly, and the case where one of them yields success definitely, without any uncertainty. And that's fine. And for general M, we just considered the case where they perform similarly. And these are the cases where we could do the analysis rigorously. And the idea is to, so if we look at CTV, the joint distribution of CTVs, okay, we want to understand how this joint law behaves. So if this joint law is mu T, let's say, then how this behaves is T goes to infinity. Okay, and because we are starting from an IID setup, the mu T will also consist of IID distributions here. So CTV will be IID a distribution of this kind. Okay, so this wouldn't be the case if we didn't start from IID. The IID structure helps, and of course the tree structure and the fact that we are looking at children helps. If we were looking at if the agent were to look at their own color, this probably is going to be a lot more complicated. And so we want to talk about talking about the limit of mu T is the same as talking about the limit of pi T as T goes to infinity. And we can say that in the limit, so mu T will converge to nu, okay, where nu is the joint law of these random variables, so let us see infinity v. So nu is the law of, so my nu and v kind of look similar, sorry about that. It's the law of these random variables where c infinity v are again IID, and c infinity v is blue with probability pi and red with probability 1 minus pi. So ultimately we want to talk about this value, right?
So is it immediate to see that CTP will continue to be IID?
Sort of. I mean, we can just look at any
It's only looking down.
finite
You're
dimensional.
getting newer and newer independent variables, and with the same function resulting.
We can look at any finite dimensional finite part of this tree, so up to a finite level.
So each node has the same number of children.
Yeah, this by it's TM. Okay, so in order to do that, so we want to sort of get a reference relation which connects pi t with pi t plus 1 and so on, and then take a limit as t goes to infinity. So sort of that forms the crux of the argument. So I will erase this part. Oh, okay. Oh, so the okay. much time do I have?
We have used about 12 minutes.
Okay. Okay. So, so the idea is as follows. So now we want to find a reference for the sequence pi t. So let's say we condition on the following event. So ultimately we would condition on this event, that's sum. So this is B, B1, B2, call it Bk later, up to Bm. So we will condition on this sum, which is this number of children who have adopted technology B during epoch T, to be equal to K. We will condition on this event. And for that, I'm just looking at the first K children, and I'm saying that, okay, they have adopted blue, and the remaining M minus K have adopted red. So these, let's say, are all blue, these are all red. So then, what is the probability of, so I want to look at probability that Ct plus 1 of B equal to B given this event. But this is the same as if we say that B1 through Bk have adopted B, and Bk plus 1 through Bn have adopted red. So then this becomes the same as saying summation j running from 1 through k, no longer any need for indicators because I have fixed the colors now. This is either strictly bigger than this, right? Because now the first k are blue, the last n minus k are red. This is one possibility, or where the tie happens, there we have summation j running from 1 through k, xt bj is equal to summation j running from k plus 1 through m, xt bj. Now this thing, because we are conditioning on them having adopted the color blue, we know that each xtbj here, where j is between 1 and k, follows Bernoulli P sub b, right? So this will follow binomial k P sub b, okay, and then this part will follow similarly binomial m minus k and success probability P sub r. Okay, so if I call this part, so if I say that ak is a random variable that follows binomial k comma P sub b, and bm minus k is another random variable. The two will be independent. I'll write that. So this one follows binomial n minus k comma P sub r, and ak, bm minus k are independent. Okay, so then we are able to say that this thing just boils down to this one, just boils down to probability ak greater than bm minus k plus half probability ak equal to bm minus, and we will give this a name. This is f sub m of k. So then when we want to find the unconditioned marginal, just this probability, so then it's just this conditional probability times the probability of this event. So exactly k many of the children have adopted or did adopt blue in the previous epoch. So this one we have just, this part is f sub m of k. So that's summation k running from 0 to m, f sub m of k. And here, what we are claiming is that out of the m children, precisely k, chose to adopt blue, and this was during the previous epoch. So this was, every one of them adopted blue with probability phi sub t, which is this here. And this is IID, it's independently done. So we choose which of them adopted blue, and then just that. Okay. So and this is phi sub t plus 1. Okay. So we get this recurrence, and now when the limit exists, so then we and the limit can be shown to exist. So then as we take the t goes to infinity on both sides, we end up getting the phi, which is limit t going to infinity pi sub t. This satisfies, or I should say, is a fixed point. Okay. Is a fixed point of the function g of x, which is summation p running from 0 to m, f sub m of k, m choose k, x to the k, 1 minus x to the m minus k. So we have to analyze the fixed points of this function within the interval 0, 1. Thank you. So what we end up showing, so let me write down the